So the 25th Space Shuttle mission is now on the way after more delays than NASA cares to count. This morning, it looked as though they were not going to be able to get off.
1 minute, 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles.
Looks like a couple of the solid rocket boosters blew away from the side of the shuttle in an explosion.
Flight controllers here looking very carefully at the situation. Obviously a major malfunction. We have no downlink.
We're awaiting word. They're holding their breath just, I'm sure, as everyone else is. You saw it just a few moments ago, about 45 seconds after liftoff, a huge fireball in the sky.
We have a report from the flight dynamics officer that the vehicle has exploded. Flight director confirms that. We are looking at checking with the recovery forces to see what can be done at this point. Contingency procedures are in effect.
What you have just seen was an event that changed NASA's expeditions into space forever. On January 28, 1986, the Space Shuttle Challenger malfunctioned, causing an explosion that resulted in the death of the entire crew. This presentation will not only cover the specifics of the Challenger and the crash, but present the aftermath of the crash and how it affected the future of space exploration. The launch in 1986 was not this shuttle's first launch. The first launch was back almost 3 years prior, on April 4, 1983. The Shuttle Challenger, first referred to as STA-099, actually had several milestones in its name. It was the first to launch the first American woman, Sally Ride, into space, as well as carry 2 female U.S. astronauts for the first time. It was also the first to launch and land at night on a mission, and the first to land at Kennedy Space Center. In addition to these achievements, the Challenger carried many space labs and hosted many scientific experiments during its time.
The Challenger was originally created just to be a test vehicle. It was created with a lighter frame set to test that it would be able to handle space travel. In 1979, it was contracted to become a space orbiter. Although it was the simplest option, it still required the replacement of many of its parts. It took until 1982 to complete the transition. The original launch date for the Challenger was on January 22nd. However, it was delayed so far back for several different reasons. There was a delay on a previous mission initially. Then there were delays due to bad weather. Then, lastly, there were delays because of issues with the access hatch. Despite all these factors, the launch was only delayed 6 days. However, there were concerns because of the weather on the actual launch date. The temperature was -1 degree Celsius, and the Challenger was never certified to fly in temperatures that low. -1 degree Celsius is the lowest temperature that is able to fly, so they did proceed. This was the factor that caused the crash, but we will get to that later. The last mission that the Challenger attempted was named STS-51L. The goal of this mission was to deploy a tracking and data relay satellite to launch the Spartan 203, also known as the Shuttle Pointed Tool for Astronomy, which was to observe Halley's Comet. The crew consisted of 7 members. The first being the commander, Francis R. Scobie. He served in the U.S. Air Force while also earning his Bachelor of Science degree in Aerospace Engineering. He then attended the USAF Aerospace Research Pilot School and was later permitted to the NASA Astronaut Corps. This flight was not his first on the Challenger. In 1984, he piloted the Challenger in the STS-41-C mission. The pilot of the mission was named Michael John Smith. He had his Bachelor of Science degree in Naval Science and a Master of Science degree in Aeronautical Engineering. He also completed a tour in the Vietnam War. This Challenger flight was his first. Ellison Onizuka was a mission specialist on the flight. He had a Bachelor of Science degree and a Master's in Aerospace Engineering. In addition, he was part of the Air Force. He completed the astronaut program and was a mission specialist on the STS-51-C mission, which was flown on the Space Shuttle Discovery. The next member was also a mission specialist by the name of Judith Resnick. She had her Bachelor of Science in Electrical Engineering and a PhD in Electrical Engineering. She was recruited into the astronaut program and went on the STS-41-D mission aboard the Space Shuttle Discovery, its first mission. Resnick was actually a second female American in space, but the first Jewish woman. The last mission specialist was Ronald McNair. He had a Bachelor of Science degree in Engineering, Physics, and a PhD in Physics. After being accepted into the astronaut program, he flew aboard the Challenger in the STS-41-B mission. This made him the second African American to fly in space. The next crew member aboard was Greg Jarvis. He was a payload specialist. A payload specialist is not necessarily a career astronaut. They are people who have been trained for flights by specific organizations. Jarvis was representing Hughes Aircraft. He had his Bachelor of Science and Master's degree in Electrical Engineering. He also was part of the Air Force before being honorably discharged and working for Hughes Aircraft. The last crew member was another payload specialist, Sharon Krista McCullough. She was on board the Teacher in Space program. This program was to motivate students to potentially pursue careers in space exploration. McCullough was the first and last teacher selected for this program. She had a bachelor's degree in education and history and a master's in education supervision and administration. She was a teacher from Concord High School in New Hampshire and planned to have lessons in space to show her students. As previously mentioned, there were no survivors of this crew. Their deaths were not taken lightly by NASA, especially the payload specialists. The crash was due to the low temperature during liftoff. The O-rings were not meant to be used in such low temperatures. O-rings are gaskets used to be seals. They compress between 2 or more parts to seal an interface. However, when under cold temperatures, they lose their ability to compress fully. In the case of the Challenger, the O-rings became brittle and did not fully seal. This caused incredibly high temperature gas to leak through and hit the external tank. This caused the explosion. This force caused the hydrogen tank to crash into the liquid oxygen tank, creating a fireball that ripped apart the shuttle. Part of this breakup resulted in the crew's cabin splitting from the shuttle and free falling. During this falling, at least some of the crew was most likely alive. Some of their airbags had been activated. However, the cabin landed in the water at about 207 miles per hour, which is not survivable for any human. The wreck was too destructive to truly put a perfect picture of how and when exactly the crew died. The problem involving the O-rings not only was known about, but could have been solved. The company responsible for making many of the parts used, Thiokol, did not believe the low temperature was satisfactory for flight. During a teleconference the night before, the company actually proposed postponing the launch. However, NASA staff did not agree with this and did not want to keep pushing the date back. Some of the employees at Thiokol claimed that when the crash occurred, they all knew exactly what had happened. This oversight helped to change many ways that NASA reviews its safety procedures. After the accident, NASA sent out search and rescue teams when it was clear that all the debris had fallen. Over a week later, the cabin was found with the crew members' bodies in it. While it took some time and a few expeditions, all the bodies were recovered. President Reagan opted to give a speech on the Challenger instead of his planned State of the Union address.
Today is a day for mourning and remembering. Nancy and I are pained to the core by the tragedy of the Shuttle Challenger.
A commission was formed after the incident to investigate. It was known as the Rogers Commission. The commission consisted of the chairman, William P. Rogers, the vice chairman, Neil Armstrong, and several other members. The report they came up with did discuss the faulty O-rings. They also included the issue of NASA and Thiokol having awareness of the problem and still going ahead as planned. One of the commission members, Richard Feynman, went on television to describe the error that happened with the O-rings. He also wrote about the flaws in NASA's safety procedures and insisted they were published, despite backlash from the members of the commission. A major factor involved in this tragedy was the fact that it was so heavily broadcasted. It was broadcast live on several radio stations and televised live by CNN. One reason for this was because the Teachers in Space program. Many students ended up watching it live. The consequences of the Challenger accident were numerous and spread out to many different areas. The Challenger was supposed to be the start of the Teachers in Space program. While it was first, it was also the last. The program only had to train the teachers selected for about 5 months to become a payload specialist. This was seen as too little time to train to be in space. It was not until 1998 that NASA replaced the program with the Educator Astronaut Project. The main change here was that it required the educators chosen to quit teaching and train to become full mission specialists. Another change that came about due to the explosion was changes in O-rings. After the disaster, Thiokol seemed to put more effort into fixing this problem. Today, they use 3 O-rings instead of 2 and now have heaters to make sure they do not get too low in temperature. The Challenger is often used as an example for workplace ethics. Since there were people who were aware of the consequence and yet the accident still happened, it is used to show how dangerous it can be to not speak up. It portrays the dangers of groupthink and lack of communication. However, the biggest effect was on NASA's safety procedures. After the Rogers Commission did their investigation, they had 9 recommendations to NASA to prevent this from happening again. President Reagan backed the commission up by giving NASA 30 days to figure out how to solve the issues. One issue solved was the formation of the Office of Safety and Mission Assurance. This was created to help oversee the safety of the designs and the missions. Another issue brought to light from the explosion was the fact that there was no escape plan for the crew in place. It was after this that NASA looked closer on potential escape plans for the crew. This proved to be a difficult challenge, but eventually they did come up with emergency landings and the ability for the crew to slide out and parachute to Earth. On top of all these changes, NASA took a 32-month break from scheduling trips. While these changes were made by NASA, it was still not enough to prevent the Space Shuttle Columbia from also being destroyed in 2003. Several say the incident was also caused by oversight. The Space Shuttle Challenger, while having several successful runs, is typically only remembered for its last. Before the explosion, NASA was caught up in its success and did not pay mind to the flaws. The carelessness resulted in 7 very publicized deaths. The tragedy brought in a new period in space travel. While it did halt many ongoing projects, it helped to bring more safety concerns to light and to better prepare for space exploration.